Hello everybody, today we're going to talk about scale drawings. So remember, a scale drawing is a proportional two-dimensional, which is written 2D, means two-dimensional, drawing of an object. So it's two-dimensional, it's got length, it's got width, but it's got no height, so it's flat. A scale model is a proportional three-dimensional, 3D model of an object. So it's got length, width, and height. The measurements in scale drawings and models are proportional to the measurements of the actual object. So the scale gives the ratio that compares the measurements of the drawing or the model with the actual measurements. Okay, so it's something like this. We have 1 inch to 10 miles. This is your drawing distance, and this is your actual distance. Okay, so you've got a proportion here. Anytime you get two fractions equal, that's a proportion. Okay, so here we have a map of Michigan, and we want to know what's the actual distance D between Cadillac and Detroit. So here's Cadillac right here, here's Detroit right here. Okay, now there's what we need to do is we need to find the scale. So the scale happens to be right there. 1 centimeter is to 50 miles. So 1 centimeter is 50 miles in real life. Okay, so what we need to do is we need to figure out what's on this other side right here. So we're trying to find the actual distance. So that's going to be in miles. That's going to be X miles on the bottom. What we need to do is find out how far it is on the map between Cadillac and Detroit. So we're going to take our ruler here, and we're going to just kind of do this and estimate. Oh, it appears to be about 3.5 centimeters. So I'm going to have 3.5 centimeters up here. And now we've got a proportion we can solve. So remember, when we solve a proportion, the variable is always equal to the two diagonal numbers multiplied together divided by the other ones. So 50 times 3.5 divided by 1. So 50 times 3.5, that's going to be 150 plus 25, that's going to be 175. Divided by 1 is just 175. And this is in the bottom, so it's in miles. It's 175 miles. Now, if I'm looking at the map, notice that's a straight line right there. The roads do not go in a straight line. So the distance between the two, if I was going to have to draw it or find it on, or drive it in real life, would probably be much different than it would be going straight there. This is what we say is called as the crow flies, because the crow can fly directly there. Okay, so the liquid outer core of the Earth is 2,300 kilometers thick. We have a scale model here of the layers of the Earth. It has a scale of 1 inch to 500 kilometers. So if we look here, here's the solid inner core. Here's the liquid outer core around that. Here is the mantle around that, and then we live on this really thin little crust that's around the outside. Okay, so we have a scale. 1 inch is 500 kilometers. And here is our inner core, liquid outer core. And we know that that's 2,300 kilometers thick. So this right here is 2,300 kilometers. So we're going to go ahead and put that, we want kilometers on the bottom. So we've got to have kilometers on the bottom over here, 2,300 kilometers. So then up here we're going to have inches. So the question is how thick is that going to be on the model? How many inches? So X is going to be 2,300 times 1 is just 2,300 divided by 500. And then I can cancel those zeros. I can do this in my head now because 5 will go into 23. 4 times 4 3/5, that's 4.6. And it should be in inches. Okay, so 4.6 inches, that's B. Now be really careful about problems like this because a lot of times, especially multiple choice, they'll have 4.6 inches, 4.6 kilometers, people very often will see this first and they'll just go, oh, 4.6 kilometers, done. But it's the inches that you want. Okay? All right, a scale written without units is called a scale factor. So what happens is if I have a fraction where the units are the same on the top as the bottom, those units will cancel out, and I will be left with just a number, and that's called the scale factor. So the scale model of Sergeant Floyd Monument is 10 inches tall. The actual monument is 100 feet tall. What is the scale of the model? Okay, so the scale of the model is going to be 10 inches to 100 feet. Okay, now I can reduce that. This is 1 inch to 10 feet. But and so there's my scale. Okay, now what is the scale factor? Well, with the scale factor, I need to have the units be the same units. So I can convert either one. I can convert inches to feet or feet to inches, but it'll be easier to change the feet to inches because 10 feet is 120 inches. Now in this problem, the inches cancel out, and I'm left with just a number, 1 over 120. That is my scale factor right there. So the model is 1/120th of the actual size of the monument. Okay, here we have a scale drawing of a computer chip. Okay, and we've got on here a scale. The scale says that it's 1 centimeter to 2 millimeters. Okay, so find the perimeter and area of the computer chip in the scale drawing. So this computer chip is a centimeter by a centimeter. So this would be 1 centimeter is to 2 millimeters. Okay, but the perimeter of this is actually 4 centimeters. So then the actual perimeter is going to be in millimeters, and we just need to solve this. So this is going to be x is going to equal 4 times 2 divided by 1. So that's just 4 times 2, which is going to be 8 millimeters. Okay. Okay, so find the perimeter and area of the computer chip in the scale drawing. So we've got the perimeter right there. Actually, that's the actual, that's this answer down here. That's the actual perimeter is going to be 8 millimeters. Okay, so the perimeter and area of the computer chip. So the perimeter, I'm sorry, the perimeter here in this scale model is going to be 4 centimeters. And the area is going to be 1 times 1, or 1 square centimeter. Remember that area is always measured in square units. Okay, so we've got the actual perimeter is 8 millimeters. Now we got to find the actual area. Okay, so the actual area is going to be, okay, so this is, the model is 1 centimeter. So this is going to be 1 centimeter. 1 times 1 is 1, so it's 1 square centimeter, is to, this is 2 millimeters by 2 millimeters in the model. So this is going to be 2 times 2 is going to be 4 square millimeters. And that's going to equal, in actuality, let's see, we know that the perimeter of this thing is going to be, I'm sorry, 1 square centimeter to 1, Okay, so this is, in the model, the unit is 1. How do we want to do this? I don't like doing this with a proportion. Okay, so here's the thing. Let's look at it this way. This is, let's see, the side is 8. So the actual perimeter is 8 millimeters. So that means that each one of these is actually 2 millimeters on a side. Okay, so the area would be 2 times 2, which would be 4 square millimeters. So once you've actually figured out what these sides are, and we knew that these were 2 millimeters because of the scale, it was 1 centimeter, 2 millimeters, we can figure out the actual area was 4 millimeters. Okay, so moving right along here. We are going to do problems 1 through 35 odd, and I will see you in class next time.